Pluto. Pluto has been designated a dwarf planet, and the image here, you're seeing here Pluto and its largest moon, Charon, to scale to the United States. And as you can see, Pluto and its largest moon fit within the United States. So that gives you an idea of how small of an object Pluto is. We'll talk about the dwarf planet characteristics in the next tutorial, but here we want to talk about what do we know about Pluto. When Pluto was first discovered, one of the things that we always do when we discover something is figure out its motion and its orbit. And it was quickly discovered that Pluto's orbit is very elongated. Now this image is exaggerated for emphasis, but what it shows here is that for part of the time it's actually closer to the Sun than Neptune. And as you can see here on the dates, the last time that was true was from 1979 to 1999. Pluto's orbit takes 240 years, so 1979 plus 240. So the year 2219 will be the next time that Pluto is closer than Neptune. So odds are anybody listening to this will not be seeing that happen in their lifetime. So you see this where it looks like, the orbits cross, and you think, oh my God, Pluto and Neptune are going to collide. Well, they're not. And the main reason they're not is because of the tilt of Pluto's orbit. It does have a very, very big tilt. Now this is showing it relative to Earth here. But Neptune's orbit's about the same. It's not tilted very much either. So if Pluto and Neptune were in the same location as far as distance from the Sun and angle from the Sun, they're still not going to collide because one's going to be above the other. So it's either going to be Pluto over Neptune or Neptune over Pluto, but they're not going to hit each other. If they did end up in this configuration where they're relatively close to each other, that will probably do some dramatic things to Pluto's orbit because of Neptune having so much more mass, but they're not going to collide. Pluto has 5 moons. And these are all probably the result of a collision. So when we talked about the formation of our own moon, we found that the most plausible explanation is that our moon is the result of something colliding with Earth when Earth was still in the formation stages. Pluto, all 5 moons, composition-wise, look like they were knocked off of Pluto. The largest moon is Charon, and this was discovered by James Christie in 1979. And this is the discovery picture, and it's hard to tell, but what you're looking at here, that's Pluto. This little bump sticking off the side, that is Charon. So this was the discovery photograph. And obviously 1979 imagery of Pluto, not very good, but that was the way it was discovered. In mythology, Pluto is the god of the underworld. And to get to the underworld, you have to cross the river Styx. And Charon, actually pronounced Charon in mythology, was the boatman that would take you across the river Styx. James Christie was married to Sharon, and so he combined her name with the mythological boatman to the underworld to get the name of Charon for Pluto's moon. It wasn't until 2005 that we started finding other moons, and the first two were discovered in 2005, Nix and Hydra. And here we see imagery looks a lot better than 1979. So here we can clearly see Pluto and Charon, and here we see these two little dots. And 3 days later, you can see Charon has moved in its orbit, and these two guys have also moved in their orbit from where they were before. So that was the discovery of these two. And continuing in the underworld theme, the names Nix and Hydra come from that same mythology. One thing to notice, things are orbiting Pluto in a vertical plane. Pluto's system is like Uranus in that it is tilted about 90 degrees. So we see everything in the Pluto system kind of on its side, orbiting vertically around Pluto, and Pluto rotates on its axis in that same orientation. And then that vertical system orbits around the Sun. The last two to be discovered, also with Hubble imagery, were Kerberos and Styx, again mythological names. So Kerberos was P4, Styx was P5. It's the order they were discovered. You can see Nix and Hydra and Charon here. So at this point, as of summer 2014, Pluto has 5 moons. In a year, a spacecraft is heading to Pluto called New Horizons, and that will reach Pluto in the summer of 2015. And so it's going to do a flyby. It's not going to go into orbit, but this will give us our first actual up-close pictures of Pluto. Everything we've got is Earth-based, and the best we've got, is Hubble, but that's just outside of Earth's atmosphere in Earth orbit. So who knows what we're going to find come summer 2015. What we do know, because Pluto has a moon, that means we know the mass of Pluto, and by imaging it, we know its size. And if we combine those two, we get the density. And if we know the density, then we can figure out the composition. So based on that density, we think Pluto is a mixture of rock and ice, which sounds very familiar. We saw that as the composition of comets, plus a lot of moons have the same composition, especially the larger moons of the Jovian planets. So Pluto has similarities to comets, and remember, Pluto is located in the Kuiper Belt, which is our source for short-period comets. Pluto sort of has an atmosphere, at least part of the time. When Pluto is farthest from the Sun, temperatures at Pluto are negative 370 degrees Fahrenheit, very, very cold. At that temperature, Pluto does not have an atmosphere. It is frozen solid. And the picture here is Hubble imagery of Pluto. We can certainly see that there are features on Pluto that have different colors. We don't know what those are. So again, we're waiting on New Horizons to give us some clue about what's going on at Pluto. When Pluto is closer to the Sun, because its orbit is elongated, its distance changes enough that affects the temperature. It warms up to negative 350 degrees Fahrenheit. So balmy, balmy, negative 350 degrees Fahrenheit. But that is enough to vaporize some of the ices. And that's what this picture is showing, is this idea of the ices vaporizing and kind of spewing out the gases. So that develops a very tenuous atmosphere. Again, very much like a comet. When comets get closer to the sun's heat vaporizes the ice, and it develops a coma. Comets, we call it a coma. Here we're calling it an atmosphere, but not really different as far as what's happening. Now, I said the atmosphere was tenuous. Here's our atmospheric pressure, 1/10,000th of an atmosphere. Remember, Earth is one atmosphere. And so here, a 10,000th of Earth's atmosphere. That's less than the amount of atmosphere where the space shuttle orbits or where the space station orbits. So it's not much of an atmosphere in reality, but there are gases there. And that's about all we can say about Pluto's atmosphere.